Hello everyone. Today I will present my project on the design of a DC-DC voltage regulator with a battery energy storage system for renewable energy system. So here are the table of content, the introduction, literature review, motivation, comparison with conventional system, proposed circuit description, simulation analysis, result analysis, conclusion and future work, and references. So introduction. So, the overview. Battery energy storage system BESS play a crucial role in the stabilized power grids that rely on renewable energy sources like solar and wind power. Battery energy system enhance the performance and reliability on renewable energy system by mitigating fluctuation and ensuring a consistent energy supply. Technological advancement in battery chemistry and control system have significantly improved the efficiency and longevity of the battery energy system. Literature review. So there are some current research regarding the battery energy storage system. Uh, These studies focus on the integration of DC-DC converters with the battery energy system to enhance the reliability of the renewable energy system. There have been significant advances in hybrid energy storage system that combine batteries with supercapacitor to improve performance. The implementation of model predictive control (MPC) in bi-directional converters help to stabilize power output and manage fluctuation effectively. The motivation of this project is the addressing of the limitation. So current battery technologies faces limitations such as poor response time and limited cycle life under variable loads. By combining batteries with a supercapacitor in hybrid energy storage system, we can enhance both performance and reliability. Battery energy storage system contributed to reduce greenhouse gas emission and reliance on fossil fuel, thereby supporting global sustainability effort. So comparison with the conventional system. So in traditional system, the conventional energy storage system often relies slowly on batteries, which have limitation in response time and cycle life. The proposed system incorporate supercapacitors with batteries, enhancing performance by adding the limitation of each component. The hybrid system demonstrates higher efficiency, battery response times, and improve voltage regulation compared to conventional system. So proposed circuit. So here is our circuit diagram. You can see this design in the. So this circuit is like here we use the PV system, PID controller, and one capacitor, and two capacitor and one inductor and one resistor, and also we use two MOSFET switches. And here is our battery portion. So for in this system, we also use for simulating the system. We also use the reference variable, and uh, we also use the MPPT algorithm, the maximum power point tracking system, to optimize the power output by adjusting the converter's duty cycle based on irradiation level. Simulation analysis. So we simulated our circuit in Simulink, MATLAB Simulink. So we determine some parameters. The key parameters such as inductance, capacitance, and switching frequency were configured based on the design specification. Mm, and we also use some here you can see the three displays to get the value and know about the result. And here is our reference generator, and here we write a MATLAB code to run their PI system. Here is our PI block, and here that's the total system implemented in simulation. And the PI system actually the run the whole circuit. So for the further explanation, like our PV relay produced the energy and it supply to the load. And currently we use only low battery as a load, but in furthermore in future we are hoping to add some load in this system. Right now the battery is our load and we charging our battery from the PV panel. And in like while we are charging we use some like here is the little load like a resistor for the circuit to implement the circuit. And here we can see the data of battery status like battery's voltage, current, and that's everything from the circuit. So here is the result analysis. For result analysis we are now discussing two phase like battery charging phase and discharging phase. So here we can see the battery charging phase graph. We run the simulation in the Simulink and we get this response from the circuit. So while we are running the circuit, we are getting when the load is near to zero, or the load is less than the production of PV panel, the battery start to charge the excess energy. And when we stop running the PV panel, then battery start to discharge the energy. This actually help us to understand the battery characteristic and the response time also find from the graph. And here we can see that the charging level of the battery is going to like 121, and while it's discharging it's like from 80 to it's around 60 volt the charge drop. So the drop is because of the load we connected to the circuit. And we all in the meantime we stop the PV panel to produce the energy. So here is the conventional and our proposed systems comparison. So for the voltage gain, we get like around 43 volt from the conventional system, while we are getting 120.2 volt from the system. Here you can see the voltage gain. And for the voltage discharge, it's discharging like 31.42 volt the conventional system, while our my proposed system is discharging like 80 point from 80.2 volt. So and the response time, like the proposed conventional converters response time is 0.08 second, while our proposed converters response time is 0.04 second. So our proposed system is response time is so fast than the conventional system. So compared to every other parameter, we find out we measured that the efficiency of conventional system is only 85%, while our proposed converter efficiency is 93.2%. So it's visible that our proposed converter is more reliable and more efficient rather than the regular conventional converter. So conclusion and the future work for so we have some we are planning to do some further work with this project. So The proposed system demonstrates the significant improvement in efficiency, response time, and voltage regulation. By integrating a buck converter and employing the maximum power point tracking MPPT algorithm, we optimize the energy storage and use between the solar array and the battery. For the future research, we are looking for explore the integrating wind turbine, expanding the system to handle larger energy production capacity. We aim to develop renewable microgrid for rural area, enhancing the access to suitable energy solution. Sustainability impact of our future project. So, continued advancement in this field will contribute to a more robust and sustainable renewable energy infrastructure. By reducing greenhouse gas emissions and really, reliance on fossil fuel, the system align with global sustainability goals. The successful implementation of this project demonstrated the feasibility of combining advanced control strategies and hybrid energy storage systems to optimize renewable energy uses. Our future effort will focus on scaling these technologies to create comprehensive, sustainable energy solutions. Thank you for your attention.